Hello everyone. Now in today's video we shall learn about factorization of algebraic expressions. And after that we can move on with our next exercise. Now let us understand what does the word factorization means. Now let me give you an example. Now if I say write down 6 as a product of its factors. Now what does it mean? Now first of all, what is a factor? A factor is a number. A factor is a number which can divide the given number completely. This is a factor. In simple terms, a factor is a number which can divide the given number completely. That is a factor. Now, if I say write down 6 as a product of its factors, now what does it mean? It means that you have to write down 6 in such a way that when you multiply the two factors of 6, you will get 6. How can I write? I can write down 2 into 3. 2 is a factor of 6. 3 is also a factor of 6. Again, if you consider this definition, 2 can divide 3 completely. 2 3s are 6. 3 can divide 6 completely. 3 2s are 6. Therefore, 2 into 3 is a product of factors of 6. That is the meaning of factorization. Now, 6 has been factorized in the form of 2 into 3. That is the basic meaning of factorization. Now, in factorization, in this topic, we will be doing for algebraic expression. Now, again, in algebraic expression, how do we factorize? We factorize by taking out some common terms. Alright. Now, again, when we take out the common terms, we must have the idea of factors and multiples. Very simple things to be understood. Alright? So you must know what are factors and what are multiples. Now again, what are multiple? A multiple again is a number, okay, which is acquired after multiplying. Again, now if I say what are the multiples of 6, I can say 6. The multiples of 6 are 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24. So you are multiplying. A multiple is a number which is acquired after multiplying. When you multiply, you get multiple. Or simply you can say a multiple is a number which comes in the table of that given number. Alright, so these are some basic things about factors and multiples. Now, before we start with this factorization, let me give you some formula, some identity which are very much required in the coming exercises. Alright, so let me give you some identities. Now, these are some important identities. First one, a plus b whole thing square. The formula is a squared plus twice a into b plus b square. A minus b whole thing square. The formula is a squared minus twice ab plus b square. Next, a plus b into a minus b gives a square minus b square. Next, x plus a into x plus b. X are same here, only a and b are different. X plus a into x plus b gives you x square plus a plus b x plus a into b. Alright, so with the help of these identities, we can solve the questions that will follow in the coming exercises. Now, let us start with exercise 2e. The first question says, factorize the following expression. Now, here some algebraic expressions are given to you. Now you have to convert this algebraic expression as a product of its factors. That is the meaning of factorize. Factorize means to write down in terms of product of its factors. Now, as we have discussed in our last topic, how do we find out the factors? So, to find out the factors, the concept of common terms is very, very important. The concept of common terms. The common terms means in the given terms, what is common? Sometimes x is common, sometimes y is common, sometimes numbers are common, 2 is common in both, 3 is common, or sometimes the terms are multiple of each other. So that has to be kept in mind. So let us try with this first question, which says 18x square y minus 24xy. Now in these two terms, what is common? Common is what? Again, in another word, I can say, find out the number which can divide this also, which can divide this also. Now let us do first for numbers. 18. You can divide 18 by 2. You can divide 24 by 2. Fine. You can divide 18 by 3. 3 6 are 18. You can divide 24 by 3. 3 8 are 24. You can divide 24 by 4, but you cannot divide 18 by 4. So what is our common? Our common is 3. 3 6 are 18. 3 8 are 24. Now, here you have x square. X square means x into x. Here you have only x. So here 2x, 2 times x, 1 times x. Take out 1x outside, common. You have y, 1 time y, 1 time y. Take out y outside. Now, open the bracket. Now, 3, how much are 18? 3, 6 are 18. X into what is x square? X into x is x square. Now, y is already outside. No need to write down y. Minus. Again, 3 into 8 are 24. X, 1 are x already outside. Y, 1 are y already outside. So, no need to do. So, this is your answer. Isn't it very simple? Just the concept of common terms are very, very important. Now, let us go for next question number 2. The question says 4 into x plus y minus 6 into x plus y whole thing square. Now, if you look at these terms, x plus y and x plus y whole square, means here you have x plus y 1 time, here you have x plus y 2 times. Now what can we do? 1 time you take it out. X plus y is outside now. What is left? 4 is left, minus. 4 is left, minus. 6 is left. Now x plus y whole thing square, 1 time is outside. Only 1 time is remaining. X plus y. Now you can write down again. X plus y, 4 minus 6 into x, 6x, minus into plus minus 6 into y, 6y. That is the answer. Now, if you look at the answer, is it not product of two terms? One term into another term, one term into another term. So this is the meaning of factorization. Okay. Now let us move on to the next question number 4. Now let us check. Now there are 4 terms. Now let us check in which 2 terms do we have a common. If you look at carefully, you have ax, ab, a common. Okay? And you have 5b, 5x, 5 common. So what will I do? I'll write down together first where I can find out the common. Minus 5b minus 5x. Now you check it out. In these 2 terms, what is common? A is common. What is common? A. So take out A into x, x plus A into B, AB. Now minus. Now in these 2 terms, what is common? 5 is common. 5. Now you have taken out 5 minus 5. 5 into B minus 5B minus into plus minus 5 is outside, 5 into x, 5x. So you have seen you have x plus b, b plus x, they are same. A plus b or b plus a, they are same. So what do we do now? You can write down like this, x plus b. In this case also you can write down x plus b, no problem. Now this x plus b and this x plus b again are same, is not it? Common, take it outside. You have x plus b. Now from here you have taken out x plus b outside. What is remaining? Only a minus. This x plus b is outside. What is remaining? 5. That is the answer. Fine. Now go for next question. You have x cube minus x square plus ax plus x minus a minus 1. Now in this question, let us take out the constant, the common from these two terms separately, these two terms separately, and these two terms. Now let us find out. In these two terms there is no common, but again you can take out one common. Now from these two, what is common? You have to take out the biggest common, You have x cube, x into x into x. You have x square, x into x. So I can take out x square outside. So from x cube, from 3x means 3 times x, 2 times x is outside. What is remaining? Only 1 time x. Now here, minus x square. X square is already outside. What is remaining? Only 1. So if you multiply these two, you will get the same term. X square into x, x cube, x square into 1, x square. Now again, from these two terms, what is common? X is common. X. What is remaining? A plus 1. It's not it. Now from these two, what is common? 1 is common. Nothing is common means 1 is common. So 1 into a minus into plus minus 1 ones are 1. Is it fine? Now we have seen that I have taken out x square common from here, x common from here, and minus 1 common from here. Now what do you observe here? We observe that this and this are also common now. Is not it? This and this are also common. Now what do we do here? Write down this one as it is, x minus 1 plus. Now from these two, what is common? A plus 1, a plus 1. Take out a plus 1 outside. What is remaining now? X minus 1. Now from these two terms again, this and this are common, take it outside. X minus 1. So what is left? X square plus a plus 1. Now you can write down together x minus 1, x square plus a plus 1. That is the, is it not a product of factors? That is the meaning of factorization. Now let us move on to the next question. Number 6. It says p square plus pq into q plus 1 plus q cube. Now let us write down this one. Now if you look carefully, there are no common here at present, because p square, p, this is a product of terms again. What do we do? Here we can separate them, we can multiply them. Now I will do like this, p square plus p q into q, p q square, p q into 1, p q plus q q. Now, what do you see here from these two terms? What is common? P square p, take out p. From p square, one p is outside, only p is remaining. Plus p is outside, q square is remaining. Now from these two terms, what is common? Q is common. Take out q, what is left? P plus q square. Now if you see here, we get p plus q square, p plus q square. Both are same terms. So take it out common. P plus q square. So what is left? P plus q. That is the answer. Now let us move on to question number 7. It says a into a minus twice b minus c plus twice bc. Let us solve this one. Now again, if you look at this expression, you cannot find any common now. But we can find after multiplying individual terms with a into a square minus a into 2b, 2ab minus a into c, ac plus twice bc. Now, what do you observe here? What do you observe here now? Now, if you look at carefully, I write down this term and this term together, this term and this term together. See, a square minus ac minus 2ab plus 2bc. Now, from this two term, what is common? A is common. I'll take out a into a square minus a into c, ac. Common. Now from this two term, what is common? 2, write down 2. B, write down B. Now what is left? A minus into minus will give you plus. 2b is outside, what is left? C. Now if you look at this expression, we have a minus c, again common. So take it out. A minus c, what is left? A minus 2b. So this is our required answer. So these are some of the questions for factorization of the algebraic expression. Now let us do some more questions. You'll understand much better. It's factors. Now let us try. Now, at the beginning of this video, I've given you 4 important identities. Now from there, we will be using one identity here. Now let us check what is that. Now if you look at these 3 terms very carefully, these 3 terms, now let us look. Can I write this term as like this? X square minus 2 plus 1 by x square minus 3x plus 3 by x. Now, I am trying to convert this 3 term as a standard form which can be used as an identity. Now, I write down, I'll make it like this. A square minus twice a into b plus b square. Now, see here. Why have I done like that? Because if I cancel this x and x, I'll get 2 only. That is fine. No problem at all. Now 1 by x square, I can write down 1 by x whole thing square, because if you say 1 square, it is 1 and x square is x. Isn't that fine? Yes, that is fine. Now write down this in one bracket. Now from this 2 term, what is common? 3 is common. 3. Take out x. Minus into minus will give you plus. Don't get confused when you have minus here. Minus into what will give you this above sign that has to be kept in mind very carefully. Minus into minus will give you plus. So 3 is already outside. What is left? 1 by x. Now again, if you look at this format, if you look at this format, isn't it a standard form of a minus b whole thing square? So I'll write down a means x minus 1 by x whole thing square. Now what is left here? 3x minus 1 by x. If you look at this term again, x minus 1 by x whole square, x minus 1 by x one time. So 2 times, 1 times. Take out 1 time outside as a common. X minus 1 by x. From here, x minus 1 by x, 1 time is outside. What is remaining? X minus 1 by x is remaining. Minus 3 is remaining. X minus 1 by x. You have x minus 1 by x minus 3. That is the answer. Product of factors. That is the meaning of factorization. Let us look at this question number 10, which says 4a square plus 12ab plus 9b square minus 8a minus 12b. Again, if you look at this term very carefully, you'll find out that this is a standard form of identity, but you have to convert it first. Now 4a square, can I write twice a whole thing square? Plus, first I write down this one. 9b square, I can write down 3b whole thing square. If you check, 2 square, 4, a square, 3 square, 9, b square is b square. Now, check it out. A square plus twice, a means twice a, b means 3b. Now, if you multiply them, 2 2s are 4, 4 3s are 12, a into b. Isn't it interesting now? Yes. Now let us come here, minus 8a minus 12b. Write down this in bracket. Now if you look at this, a square plus twice ab plus b square. Isn't it in the form of a plus b whole thing square? Now this everything behaves as a, this behaves as b. Now from this two term, what is common? 4. 4 2s are a, 8, a, minus into plus will give you minus. Do not get confused when there is minus. Minus into what will give you minus? You have to check it out in this way. Minus into plus will give you minus. 4 3s are 12b. Now if you look at these two terms, you'll find out that, you'll see that 2a plus 3b, 2a plus 3b common. But here 2 times, here 1 time. So take it out, 1 time common. 2a plus 3b. Out, what is remaining? 2a plus 3b. From here 2a plus 3b is outside. What is remaining? Minus 4. Now I write down like this. 2a plus 3b. 2a plus 3b minus 4. That is the answer. Now let us move on to this number 12. Now if you look at this question carefully, you will see that you cannot take out common now. But I can make some changes here. What will I do? I write down a square, x square, and I write down this a here. Now why do I write a here? Because I have observed that here a square, here a. I can take out a common easily. That is why I have written this here. Write down the remaining term into x. Now from these two terms, a is common. Now a square, from a square 1a is outside. What is remaining? Only a, x square plus a is outside. What is remaining? 1. Write down remaining as it is. Now from these two terms, if you observe carefully, common, take it out. This is outside. What is remaining? This is outside. What is remaining? That is the required answer. So, this is how we factorize an algebraic expression. So, you must have the concept of the concept of common terms, factors and multiples. Alright? So, these small things will be very helpful in solving such type of questions, in converting, in factorizing such types of questions. Let us do few questions more, then the exercise will be over. Let us try these questions. Now question 13 says 27a square minus 48b square. Let us solve this question. Now what can I do? I will directly take out common first. I'll write down 3 9s are 27 a square minus 3 16s are 48 b square. Now 3. If you look at this term 9a, isn't it like this? 3a whole thing square. Again 16b square means 4b whole thing square. If you check 3 square means 9, a square is a square minus 4 square means 16, b square is b square. Now again, if you recollect the identities that I have given at the beginning of this video, you have a square minus b square. A square minus b square says a plus b into a minus b. Now this is a, b. A, b. I can write down 3. I'll remove this curly bracket. A plus 4b in 3a minus 4b. That is the required answer. Now if you look at this next question, number 16, x square minus y square plus 6y minus 9. You have x square minus y square plus 6y minus 9. Now x square. Now from these three terms, take out minus common. Minus 1, you'll have y square. Minus into minus will give you plus 6y. Minus into plus will give you 9. Fine. Now isn't this a quadratic equation? Now you have to do the middle term here. Now how to do middle term? Take out the LCM of 9. I'll do here. 3 3s are 9. 3 1s are 3. Now 9 1s are 9. 9 1 is the coefficient of y square 1. So 9 1s are 9. Take out the LCM of 9. You get 3 into 3. Now when you add or subtract, you must get 6. That means we get 6 by 3 plus 3. So what do I write here? X square minus 1 y square minus 3 plus 3 y plus 9. Now next, y square minus 3y minus into minus, minus into plus minus 3y plus 9. Now you have to take out common again. What is common in these two? Y is common. You will have y minus 3. What is common in these two? 3 is common. 3 y minus into minus will give you plus. 3 3s are 9. If you look at this term and this term, they are common. X square minus 1 y minus 3. What is that? Y minus 3. Now if you look at this one, y minus 3, y minus 3, y minus 3 whole thing square. It's not it. Now again, if you look at this identity, same that I have used here, a square minus b square, a square minus b square formula. A plus b, a minus b. Last line, you can write down x plus y minus 3, x minus y, minus into minus plus 3. That is the answer. Now let us go for the last question of this exercise. It says x to the power 4 minus 625. Now this one I have to convert again. Now see. First of all, take out the LCM of 625. I'll do here. 5 1s are 5. 5 2s are 10. 5 5s are 25. 5 2s are 5. 5 to 25. Again, 5 5s are 25. 5 1s are. So what do you get? Will I not get 5 to the power 4? Yes, I will get 5 to the power 4. Now, I will write down like this. X square whole thing square minus 5 square whole thing square. Because when you have power upon power, the powers are multiplied. 2 2s are 4. 2 2s are 4. Again, when you have power upon power, power on top of power, you can multiply the powers. Now, if you look at the identity again, isn't it a square minus b square? This everything behaves as a. B, a square minus b square formula. A plus b, a minus b. Now this one I can write down a square plus 25. Now again, if you look at this one, a square minus b square, again formula. A plus b, a minus b. So finally I can write down x square plus 25, x plus 5, x minus 5. That is the answer. Now with this we come to the end of exercise 2e. Now there are some more questions in the book, similar type of questions that we have solved here. You can practice those questions. Any queries you can leave in the comment section. I'll try to solve in my next video. Thank you very much.